Good,
Good.
Aisha. Hi.
All right. Well, good afternoon, everyone. What we're going to cover today are sort of EduSmart resources that you can use in a theme. So I'm calling it Fall into Learning. And because I know districts don't always have the same scope and sequence, that I've pulled examples from each reporting category. So depending on what you're teaching now, you should find a way to make this fit. So my name is Lisa Delarier, and I am the Director of Content here at EduSmart. So what we're going to cover today are examples of activities where we're going to do some science with Halloween candy. We're going to do relative density because we know that some objects or substances can fall to the bottom of a container. Then we're going to go through an engineering design challenge where the kids are trying to keep Bigfoot from falling into the water. And then for light and seasons, how do we know when it's fall? We're going to briefly go over how you can do a pumpkin decomposition, which is really fun to do. And then an activity where we model animal behavior in the fall. So if you have any questions as we go along, just feel free to speak up. I'm very informal. So the candy lab that we're going to do, Halloween candy, is with M&Ms. So I make a note of this later, but if you're not allowed to have candy on your campus, this is a great activity to send home and let the kids do at home because it's very simple. So they learn in 4th and 5th grade about mixtures. And so this is a way to either help introduce that or reinforce it if you're at an upper grade. And the color dye that M&M candy is made from has more than one color most of the time. It depends on the color. And so if you put some of that dye substance on a filter paper and you put it in water so that you don't put it underwater, the water will move up the paper and separate those colors. And so my recommendation is to let them understand that that movement is based on size, that if there's more than one dye, they're not always the same size. And the ones that are smaller will move up the paper faster than the ones that are not. And to have them understand that it takes more than one color sometimes to make one of those candy colors that you'll find on an M&M. So these are the kids' directions, just to go through it briefly. You'll need some filter paper. My recommendation is to use a coffee filter paper, and the ones that are the conical ones work best because they're a little bit thicker. You need paper that's absorbent so the water will pull its way up the paper. And all they do is lick one side of the M&M and press it down on the paper to try to get that colored dye off. And then you hang it. Since this dye is water soluble, you can just put it in water and the kids can watch the dye move up the filter paper and they can see if it's made of more than one color or not. If you want to model this in advance without candy, you can also do it with a washable marker. I'd pick a black because it's going to show more colors. And then you can do the same thing. If you use a permanent marker, that won't work because it's not soluble in water. So you can also cover solubility depending on what grade that you're covering. So have the kids make predictions, watch what happens, record results by drawing what they see. So this is the teacher's advanced preparation. I would cut up the filter paper in advance and also punch the holes in it. Make sure it can hang in a clear plastic cup so they can see what's going on without touching the bottom of the cup. And you can, like I just said, demonstrate by using a washable marker instead of the candy coating. And a black will work best. And again, this is an easy one to send home that they'll be able to do at home. So that went a lot faster than I thought, but I'm also giving you a copy of the activity itself where you get the student facing view and there'll be a teacher edition at the end of this. Has anyone ever done an activity like this before? I can't see the chat, so.
Yes, I have.
We did something similar just for a science night last year. It was
Okay.
multiplications, and we did it with the ink. So
okay.
I think the candy would be an interesting I think they pay more attention when it's candy versus.
Exactly. That's why I always use candy. Although I have done like a forensics lab where I used a different washable marker to write the ransom note, and they had to figure out which pen
That's
it came from.
that's what kind of what we did during science night. There
Okay.
was pet hair to be investigated under a microscope, and then there was
Okay.
ink. We were looking at the ink on the ransom note, all of the things. So yeah.
Okay. Well, good. Well, good. So this fits in with the fall theme because there's lots of Halloween candy available. They may want to take it further once they see how simple this is to do and try to test other candy like Skittles or something that has a dye attached to it to see if it works for that. I'm not sure all the dyes on other candies are water soluble. I haven't tried them all, but I know for a fact it works for M&Ms and washable markers.
We've done it before in STEM Girls with Skittles, and that seemed to
Okay.
work pretty well too. So
Okay. Okay.
It worked.
Good.
The Skittles worked the same with just them moistening it with like their saliva, and they were able to get the color off.
Yes.
Okay.
Okay.
Okay. Perfect.
but unlike the M&Ms, it does not necessarily have two, it's not made up of two colors, so they're not seeing the separation of colors.
Okay.
Oh, so a different kind of dye.
A
Okay.
different kind of dye. So the M&Ms are much more, it's going to bring in that multiple colors and combine the
Right.
colors.
Right. Yeah, the brown definitely separates into more than one color. But let them make predictions. Some of them do, some of them don't. So it's always good to not know the answer in advance. And I threw a couple Halloween sort of science comics to segue between activities. I also wanted to point out that we have an anchoring phenomenon that shows up in our LMS. It's not going to be visible at every grade level. And so I think it shows up in 5th grade. So if you're not in 5th grade, you're not going to be able to see it. But I just wanted to show the picture, and maybe you could find a YouTube video if you don't have access to other grade levels. But to have them see that rocks can float is usually a good anchoring phenomenon for them to wonder what's going on, why is that rock floating, and to have them connected back to relative density. And then maybe in upper grades, predict what kind of properties those floating rocks have. How are they able to float? Always a good segue into talking about rocks. And then on that same idea of density, this is one of my favorite activities to do, where the kids are challenged to layer liquids. So you prepare 4 different liquids that have different densities, and they will predict which layer will go to the bottom, which will be next, which will be on the top, etc. And so you have them, this is a short, so it's really good for them to come up with their own procedure for how to do it. How are you going to collect data? How are you going to record your data? And only then, once they do that, and of course, make a prediction first, will they be able to do the activity itself, and to have a method of communicating their results. So the guiding question, how does the density of different liquids affect the layering between those liquids? So these are the guide for the kids. You're going to layer 4 different mystery liquids. Can you predict how they'll stack up? And then you're going to be able to have you rank them according to their density. Which one will fall to the bottom? And so another reason I like this activity, because layering liquids can get kind of messy. And I don't know about you, but I don't like to clean out graduated cylinders, especially if there's something sticky in there. So you can use a straw or half a straw, and you can make a little mini graduated cylinder, because you're not measuring volume, you're just seeing what layers they go in. And so if you take that straw and you push it down into a fairly thick layer of potato, just as long as you don't go all the way through, it will stay there long enough to make that density column without leaking out the bottom. And of course, the best part of this is cleanup. You just toss the whole thing in the trash. You can also put more than 1 straw in each slice, so that it limits how many potatoes you would have to do. You don't need 1 potato per straw. You just move over and find a different spot to put the straw in, and then they will add the liquids by using a dropping pipette. Has anyone ever tried to do a graduated cylinder like this?
I have, and it's not fun to clean up at all.
Oh, yeah. Oh, the regular graduated cylinder. These are super easy with the potato base. Just throw them all in the trash can. There's no
But
cleanup. I
do you
cut the potatoes, so we don't have to worry about giving kids a knife, but I'm sorry, I interrupted someone.
Is there a list of liquids that you,
Yes.
okay,
So obviously you need something that is very dense to go at the bottom. I purposely didn't match the colors in the example given on the student sheet. These are not the right order. It's not going to go red, blue, yellow, green because you don't want to give away the answer. And so here is the liquids that I used. You could substitute as long as it ranked in density like this. So glycerin is at the bottom. You can buy it at any drugstore. It has a density, of course, greater than water. So it's going to go to the bottom. Then I made some salt water. For this, I would advise using kosher salt because when it dissolves, it's not cloudy. Table salt has preservatives in it that make it cloudy, and the iodine can make it cloudy. But kosher salt doesn't have that. So you have a clear saltwater solution. The exact concentration isn't super important, but the more you put in there, the better it will be. But of course, you don't want the salt to go to the bottom of the container. And then the next one is just water. And then the top one is rubbing alcohol, which I colored red. And so they figure out pretty quick that the blue is going to go to the bottom because if they add it, if it's not the first they put in, which it probably won't be, it will sink to the bottom under another liquid. And so they get that down pretty good. Also the red floating on the top, it doesn't always move up to the top as well as the blue move to the bottom. But it's the two in the middle that can make them sort of do the most work. Because if you put them in the correct order of density, like the most dense and then the least dense, so put salt water and then water, it will layer. But if you flip those and put water in the bottom and salt water above it, they'll mix together. So a little bit of a challenge where they have to stop and think, wait a minute, what do I need to do to make these stack up inside the straw in the correct order? And of course, you don't give them the key to this. Anyone ever used a different substance that might be easier to manage? Corn syrup's a little too thick.
I used corn syrup and dishwashing liquid one time.
Okay. Yeah, dishwashing liquid's a good idea and just go with the color that it already is.
Yeah, and then I didn't have to because it was
Right.
already blue.
Right. Yeah, that'll work. You can use shampoo, too. Sometimes those have different colors. I like to have them all be clear, but it doesn't have to be that way. But I seriously have done this lab a million times. I don't even know how many professional developments where we did this so the teachers could experience themselves. And it's always gone successfully and always had an easy cleanup. I just gave the kids like a paper plate to put their potato on and work from there. There usually weren't very many spills because there are low volumes of liquid. And so
Lisa, I just want to say on this activity, it's so much better than like the lava lamp that a lot of times teachers will do for this because it's so open-ended and inquiry based as opposed to step-by-step formulaic. Here, add this, then add this, then add this. This is completely open inquiry and it makes it so much more impactful. So I love this one.
It's something easy for them to sort of get a start on writing their own procedure, coming up with their own questions. How do I organize the data? There's not a lot of procedure or a lot of data. So yeah, I think it works real well for that. And it's usually done near the beginning of the year if you do the physical or the first reporting category first, the matter and energy. I've done it also with third grade teachers all the way up to 8th grade teachers. The science is the same. I don't think the older kids would actually do this any faster than the younger ones would. Sort
They
of.
will, my kids will overthink the procedures and writing.
Oh,
So it will take the 8th graders just as
Yeah.
long, if not longer.
I hear you. Yeah,
Mhm.
I didn't think about that. You're right. But it's just simple, easy, and at least for me, it's always worked. They understand density a lot better after this. So, and then for the next one, I threw in a engineering design challenge, because the purpose of this is for the kids to make something that will keep Bigfoot from falling off a raft. And so there's a little story behind the engineering design challenges we have. And so this one, Bigfoot has a problem. He needs to cross a dangerous river without falling in, and he can't do it by himself. You're going to need to help him. So the student challenge is designed and build a strong raft that can carry Bigfoot safely across the river. You'll test different materials, shapes, and designs to make sure Bigfoot stays dry and safe. This is your chance to be inventive, resourceful, and brave as you help Bigfoot on this journey. And so I didn't put a separate slide for this, but for our engineering design challenges, we use a process called GRASPS, GRASPS. And so I listed it out here to sort of, this sets the framework for how the kids are supposed to look at this engineering design. So you give them a goal. You have to design and construct a raft that Bigfoot won't fall off of. Your role. So what are you doing? You're part of a secret team of engineers that is trying to keep Bigfoot from getting discovered, and you have to get him across the river. Your audience is Bigfoot himself. He's waiting for you to build the raft so he can reach the other side of the river without getting his beautiful fur wet. So the situation, Bigfoot is on one side of a river and he needs to get across the other river to safety. So you're going to use your skills and knowledge of physical properties of matter to design a raft that can float Bigfoot across a river. And so your product is going to be the actual model that you make. You have to use the materials that are provided. Those will be limited. And you are given parameters of how big your raft can be, not how small. And so it can't be larger than 10 centimeters square, which is about 4 inches square. And so this is your model of the raft that Bigfoot is going to ride in. We tried to use the word model a lot because it shows up in our SCPs now. And we need to make sure that kids understand there are different kind of models, and this one is a physical one. Uh-oh. Let me try this. There we go. And how will you know if you're successful? Your raft needs to be stable and well constructed. You and your team will also need to demonstrate your knowledge of the properties of the materials you use that help your raft keep Bigfoot safe and dry. And so these are some examples of materials I've done doing teacher workshops with this. Just some cardboard, aluminum foil, cling wrap, tape, straws, bubble envelopes, etc. Mainly I just save Amazon packaging in a tub and bring it with me. And your Bigfoot model is also very simple. I just put a ½ cup of rice in a zip tuck bag and then taped it up so it's like a square. And that's Bigfoot. So when they test their raft, they bring it to the river and you put Bigfoot on top of the raft, and either Bigfoot stays on the raft or he falls off. And because this is engineering design, if he falls off the raft, you have to go back and make another prototype. And for the kids who get this down the first time, I'll pull out my extra big Bigfoot where it's twice as big. It's a cup of rice to try to make it more challenging for them. So everybody's not waiting on one group to finish. And so I put an image of the cover of this activity. You'll get a PDF copy of every activity. At the end of this, I have a Google Drive where I'm going to share everything. So this talks a little bit more to the kids in the background about what an engineer does, and engineers solve problems, to just distinguish it from a science activity. It also has a rubric where the kids can evaluate themselves on how well they did on each part of this. Also to make it slightly different than a science activity. So it has to do with falling off into a river, but that's a little bit density and a little bit buoyancy. I would not go in elementary too far past understanding that you just have to make something, just think of the properties you need to make Bigfoot float and don't talk about why he's floating. It's still a good engineering design activity. Any questions, comments on how we could improve this? I know you didn't see the whole entire activity, but we are very proud of our engineering design activities, and this is one of my favorite ones.
I will say when we took this to CAST, was it last year? Oh my goodness, this was definitely one of the best sessions that we had. When everyone was, when all the teachers were having trouble getting Bigfoot floating across. It can be really challenging depending on how you curate those materials.
Right.
And I love this for like around Halloween because it's a monster, right? It's a Halloween kind of idea, but it's Bigfoot. So it's not going to conflict with anyone who's, you know, religious values or something don't allow them to celebrate Halloween. So it's really inclusive. Yeah,
that's a good point. I also, for those workshops, you can buy little tiny Bigfoot, I don't know how to say it, from Amazon. They're seriously a little over an inch tall. And for those teacher workshops, I would tape the little Bigfoot on top of the bag of rice just to make it more visually appealing.
I have mine here somewhere. I was going to bring it out, but I can't find it right now. But I still have him. I love my Bigfoot. He's like that big.
I have some in a box somewhere, just in case I need to take this on the road again. So, but I didn't pull them out for this.
I have a collection of miniatures. We could do a Yoda. These are the things to show.
Yeah.
These are the cool this year. We could do Jesus because they all have the miniature Jesus.
Walking on water.
I got a dinosaur last week.
Oh, how cute.
And the alien. So if I don't have a Bigfoot, I've got something I can float.
Yeah, obviously the Bigfoot can be changed to anything. It might, you know, whatever would interest your kids the most, but we wrote it as Bigfoot.
I love it.
So moving on to Earth and space science, I need to pick up the pace here. How do we know when it's fall? And understanding the seasons is sometimes very difficult for people to understand, not just elementary people, but even adults, because they don't understand the tilted Earth and the moving around the sun and northern sun and southern hemisphere. And so for this activity, I tried to break it down to where we're just talking about the energy. And so this is also a very simple activity, but very powerful and effective. You need a flashlight. It can be a little mini flashlight. The size doesn't really matter. I usually use a cardboard paper towel tube to kind of direct the light so it doesn't diffuse coming right out of the flashlight. You need some graph paper. I call them energy pieces, but I usually do it with M&Ms. But you can use dried beans. You can use whatever will work in your class if they don't want you to have candy. Now the ruler, I don't remember what that's for, but you definitely need 2 colors of crayons. I modified this. And so again, the cardboard tube is to prevent light from spreading out. And what you're showing them, we're going to be comparing direct sunlight like summer to indirect sunlight that you would have in the fall and in the spring, but we're focusing on fall here. And so what you have them do is shine that flashlight straight down and draw a circle with a crayon around the area that shines on the paper from the flashlight held above. And then you have them hold it to the side so that it's tilted, and it's not going to make a circle on the bottom of this. It's going to make more of an oval shape. And so you do that at the bottom and you call it fall. And then the next step is to use either candy or those energy pieces. And inside every intact square, you put a candy or a bean or something that will fit inside. And that's the amount of energy coming from the sun down to the earth. Okay. But what you have to do when you teach, what is it going to do in the fall? You can only move the candy from the summer circle down into the fall, because the sun doesn't have more energy in the fall than it does in the summer. So you don't get more candy, you don't get more energy. And so you have to move that sun's energy from the summer into the fall shape. And what you notice is that it's not as concentrated. And so if you see this as energy, which one would be cooler, the summer or the fall? And so they'll understand why temperatures change. So super simple. It's made some of the teachers I've done in workshops understand this better. And like I said, very, very easy to do.
I like the fact that it focuses on the energy, because we've done the light before, and then we do the styrofoam balls and the lamp, and they do but
they don't
seeing the amount of energy change, I love that.
Yeah. Yeah. And it's so much easier, and you don't have them going, huh? What? Because it's hard to see understand that 3-dimensional model. We're here, you're just looking as, and you don't get direct sunlight all year round. And so, but you get the same amount of energy from the sun all year round. And so I think they can connect this to temperature changing pretty easily. And so I have the handout for this one too. And then, since we were talking about,
I love this one.
So I don't know if you can see it, but science says lies, because the moon doesn't shine on its own. All right. And then I have an activity that's a pumpkin decomposition. This can be done all the way from first grade all the way to high school. I taught biology for 17 years, and we would do this in my class, not with too many examples, because I would teach over 200 students, but I had one for each class for this pumpkin decomposition. That if you seal that pumpkin inside a bottle, or you seal a piece of a pumpkin inside the bottle, it's very easy to follow the decay of that pumpkin over time. And so it helps them understand cycling of matter. It helps them understand life cycles. And so all I would do was cut the top off of a 2-liter bottle, big enough to either put one of those tiny pumpkins in, or just a hunk of pumpkin that still has some of the fiber and seeds on it, so that you can put it in the bottom of this 2-liter bottle that has some dirt or potting soil on the bottom. A little bit of water, but it doesn't have to be saturated. And then you can have kids do variables for this. First grade, you just would watch it. But as you get older, you can say, can we compare a pumpkin that's been cut versus one that has not been cut? Or can we compare a pumpkin that's been cut and put outside versus one that's been inside, and they've been exposed to more different things? Or you can leave one outside versus inside, where they'll have different temperatures. And so you can change the variables depending on the level of your kids. But again, make sure you've got some seeds inside. And then you can just tape the top back on. I just use clear packing tape, and they just observe over time. We do not take the lid off of the container. And so for younger ones, I probably would recommend super gluing the lid on, so that they don't unscrew it, because it is not going to smell very good after time. And so I made a sample observation log. You can either use this or have the kids come up with their own, depending on their grade. And just to let teachers know, over the weeks and month, you're going to see the mold grow, and then it's going to get soft. It's going to shrink because it's drying up. It's going to make some very unpleasant odors, which you won't notice until you take it outside and take the lid off, which you won't do until later, or maybe you will never do. And then eventually the pumpkin will collapse and disintegrate, returning its molecules and nutrients to the soil. And if you're going to use it to teach life cycle, we're not done yet. Because if you leave it in that bottle and expose it to sunlight, those seedlings are going to hatch, or germinate, sorry, and they'll come out of the decomposed pumpkin and start to grow inside the container. Last year, I opened a pumpkin and it already had seedlings inside. So that was a great teachable moment. I wasn't successful at getting them to grow. because I have dogs that eat this. If I had more land, I would grow pumpkins from it. And so you can transplant, you can either move those seedlings outside, or you can put them in a small paper cup and let kids take them home and see if they can continue to get them to grow. If you have a place to put them outside, they get really big. Once it's over about 70 degrees, they'll just start growing and growing. And of course, hitting maturity right about this time of year in the fall. So again, the handout has directions on what to do. And I like this one too.
Me too.
So gotta have our jokes here. And then I wanted to do something about how animals change behavior in the fall. And I just picked hummingbird migration as an example. And how do they know when to move south for the winter? Exactly when they do that migration is due to several things: how much daylight is available, what's the outside temperature, how many flowers are left that still have enough nectar to sustain them. And they can somehow manage all this and know exactly when the best time it is to migrate further south. And so students are going to be modeling, they're going to be a hummingbird that has to migrate. They're going to collect data on relationship between temperature and the amount of nectar that's available to have them understand how the birds would know how to do this. So this is background that we picked a ruby-throated hummingbird because every hummingbird is going to have a different range. But they breed in the eastern part of North America, the blue part. The purple part is a migratory route, but they can also go from blue all the way down to the orange here. They don't have to follow that route. They can go over the ocean. And then the wintering sites are down here in southern Mexico and Central America, but they don't breed there. They don't lay eggs until they come back up north for the next summer. So they can't just stay down there where it's warmer. So that's part of this, understanding this too. So again, when do they do this is a combination of how much sunlight, the temperature, and how much nectar. And so you're going to set up flowers with nectar inside. So you can use cup, and I just put 3 different colors of flower nectar in this. You could do more, but I was trying to keep it simple. And so your hummingbird has to get at least 1 of each color flower. And the more food it can get, the better it's able to survive. And so you can just make nectar tokens. If you already have something that are these colors, that's fine, but I wasn't gonna make this a circle because it's easier to cut squares out of paper. So here are the directions the kids are given. For round 1, 1 person from each group will collect nectar tokens without looking in the cup, and you bring 1 back to the team. And you keep doing that until the time runs out. All rounds are timed. And then you record your data and you have to say, did you survive or not? With all this nectar that you collected, did you get all 3 colors? And if you didn't, then you're gonna have to sit out till the next, the game, because this goes really fast. For round 2, you started in the north, but for round 2, the temperature went down a little. And so are you gonna stay where you are? Or are you going to move a little bit south? And this is where the game can get tricky, because if everyone moves south immediately, there's not as much food, because the southern part of the range is also experiencing fall, even though the temperatures may be warmer than it is up in Canada. And so if everybody moves too early, then they're going to run out of food before they can get to their final spot. So I set it up as 6 rounds where we start off warm, we get cooler, 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 cooler in the north, and then it starts to warm back up again so they can see that this is a cycle. And so they'll write down their number and color of the nectar tokens. Did they survive? And then they have to decide, are they going to stay in the north or are they going to move midway down? And like I said, if everybody moves down too fast, those cups don't have as much nectar in them. And the cups, when you get to the final place in Mexico and Central America, it's not their summer season either. So there's not necessarily more nectar there. but they'll make the connection that this is temperature dependent. And so these are just some of the questions that I asked the kids. At what temperature did your hummingbird begin migrating south? What happened to the nectar supply as the temperatures drop? How does temperature influence migration timing? Hummingbirds don't breed in southern locations. What has to happen before they'll begin their migration back to the north? There are more questions than that, but I just put a few of them in here. And then I put a copy of the activity in a Google Drive folder that I'll share. So I'm coming up on the part where we're just about ready for questions. I think the next slide, I can't see ahead, is something different. So any comments, questions about any of this?
We had a comment about just about this investigation and how, you know, this was an amazing activity for the kids to do with the with kinetic activity for them to move around and actually experience and see and feel.
Right. And you'll have to set up the room. So north is on one side, south is on one side, and there's a middle. And it's in the teacher notes, but you put way more food in the northern part because they're starting in the summer. And then you have less food in the middle and less food at the end. Those don't have to vary that much, but you have to have a lot more food at the beginning because you want them to see, I don't have enough food. So if you time it right and everybody doesn't move lockstep either, because you can start at different places in the north. So it's a little more complicated than it looks on the surface, but what they get out of it is these animals can get clues from their environment, and that tells them when to go.
Well, this investigation has a lot of opportunity for tying into RTCs with the patterns and the trends. And it's funny that you're sharing this because when we had our IS meeting recently, I took off. That was the week of the autumnal equinox. So we talked about what's the special event this week and what happens during that special event. And then I asked the ISs to tell me some standards that were connected to that. So that's where we tied in the seasons and the patterns and the seasons. And then also this third grade standard with the third grade or second grade migration.
And it's third grade, yeah.
With temperature and changes in precipitation.
Right.
We, with the seasons, we did the daylight, the other changes that happen, shorter days, things like that. So I tried to pull in both, and I also did little comics like you did, but I did it with Snoopy.
Okay.
And the theme was kicking it off for fall because that was the week that
okay, that's great.
And I was just trying to tie in how you can ask rigorous questions with the RTCs.
Yeah.
With simple concepts of real life.
And you
plant dormancy. We also talked about plant dormancy because that's happening to our grass right now.
Right. That's that third grade, I think. Well, fifth grade has that instinctual behavioral traits. So you could cover it when you're doing that. And then it can also cover cause and effect. Those RTCs, once you get the kids thinking about them, it's very easy to apply more than one to any of the lessons that you're doing.
Right.
And I try to have a variety of science and engineering practices, but I didn't want to put all that up there and read standards to you. So it's in the teacher material, but I didn't put it here in the PowerPoint.
Well, there's so many opportunities like that, like those big concepts that you can tie in RTC so easily.
Yes.
So we're trying to take advantage of it. It was just a teaser that I did for the adults.
Yeah. But this is one I wrote special just for y'all. It's not on our LMS. We may find the best place to put it and replace another one, but it'll have to wait till next school year. But
you could probably buy like plastic little chips, kind of like bingo chips that are flowers.
Oh, okay.
Because I had like plastic bingo bears that I used whenever we did science vocabulary. Like with the kids after or before review. So the same bingo chips, and they're transparent, but they're different colors.
Okay, yeah,
And so
absolutely.
I'm pretty sure
Um,
they have flower ones, like Amazon or Oriental Trading.
Yeah, I wrote this from a perspective of a high school teacher who
Mm,
wanted to use the least amount of material as possible and the easiest to put together.
Right.
Again, because you have like 200 students, so you can't go crazy. But yeah, if you already have something that will work, absolutely, just use that. And you don't have to use these 3 colors. I just was picking common flower colors, but you also
Right,
have
'cause the
purple and
traction.
blue. Right.
I do something similar to this with the genetics. It's called transparent traits, and I use the colored overlays. I
Oh,
put them out
okay.
of mother and father bags and put them into the cups for nectar. Perfect.
Okay.
Already
Yeah,
done.
I like that. Yeah. All right, then. So do you want to do this, Leah, or do you
Sure.
want me to?
Sure. So EduSmart has started a new program where we're recognizing our teachers of the month. We ask for nominations from within the districts, and we just want to celebrate the teacher in the classroom. That's kind of our whole goal. Is it's not just the program, but what makes EduSmart special is we are teacher centered, and the teachers who use us make it amazing. So this is recognizing Nancy Cardenas. She's our first teacher of the month from Mission CISD. She's a 5th grade teacher in at Salinas Elementary. And if you would go to the next slide, Lisa. So this is a quick quote from Miss Cardenas. And I'll tell you a little bit more about our interview with her later. But I love that she says this: my students inspire me every day to keep making science fun, engaging, and full of discovery. I love hearing them say that science is their favorite subject because it's so fun and time goes by super fast. And that just really, that resonated with me because in my classroom, every time the kids are like, I love science, you're like, yeah, I know, it's great. So Ms. Cardenas also said in our interview yesterday that EduSmart is her co-teacher, which just, I thought that was the best way to sum us up. You know, reading and math, they oftentimes have co-teachers come into the classroom. Science rarely gets that, but now you have EduSmart. So that's your co-teacher. So Ms. Cardenas will be recognized in our social media, our newsletter, here in the webinar, and you'll be seeing lots of clips and testimonials from her as we go through the month. If you would like to, also she got a really great classroom makeover from EduSmart, this really cool neon sign that has her name, like customized neon sign, and some other swag and some goodies just to recognize her. So if you, one more slide, Lisa. Thank you. If you know of an amazing teacher who deserves this nomination, it's a really quick and easy form to fill out. Just tell us the teacher's name and contact information and what makes this teacher so special. And then whoever nominates will also be receiving a t-shirt from EduSmart. So we want to reward the nominee who's recognizing amazing teachers within their district and their community, as well as the teachers themselves in the classroom, because teachers never can get enough credit for everything they do. So, and Ms. Cardenas was actually very tying back into the hands-on. That was her way of making science incredible for her kids, is these types of hands-on activities that let the kids actually see and experience the science and not just read about it or watch it. It's actually being part of something really special. And that's, you know, these life cycles and being able to see like that energy activity. Lisa, that blows me away. The seasons, oh my gosh, it's just so visual and so fun. I can just see the kids making those connections in the classroom. So please be sure to nominate. We have several already. We're looking for more, and we love being able to celebrate with teachers. So help us celebrate by nominating a teacher today.
Yeah. And then lastly, I have both the QR code and the bit.ly. I tried to make it customized so it's easy to remember. It's just EduSmart Fall, since this was about fall. And I did not put my email on here anywhere, but if you don't know how to find me, I'm Lisa@edusmart.com. We're usually pretty easy to get a hold of. It's just our first name at EduSmart. But again,
and Aisha, I just I'm sorry, Lisa, I
No,
didn't mean
go
to interrupt
ahead.
you, but I just looked on Amazon and they have some really cute, tiny little micro plastic flowers in orange, pink, green, and yellow, like kind of
Oh,
exact. I
yeah.
can't paste the
There you go.
link into there, but they definitely have little tiny flowers on Amazon that would work. Apparently they're like nail art, but they seem
Oh,
like exactly the
Okay,
size and everything you
yeah.
would need.
Well, if they're
And
that
it's,
tiny with little ones, you can do fine motor skill practice with it too.
yes, you can. Yes, but it's like 100 pieces for $5. So it's definitely feasible for any size classes. So yeah, that's a good idea. I didn't know that was out there either.
Yeah.
Oh, mini fairy garden accessories. Make your fairy garden.
Okay, okay. Well, again, thanks for coming. We didn't keep you too long over the promised time of 4:45, and we'll stay here if you have more questions or want to ask us anything else about EduSmart, that we're happy to stay.